Hi there, it's me, Jaffrey H. So today I want to teach you about the subject called cosmology and the universe as well. Don't worry, I'll try to keep it as simple as possible. The best definition of cosmology, in my opinion, is how the universe works, with all its knobs and buttons, as well as the beginning and origin of the universe, aka the Big Bang. The most interesting thing about the universe is that as you look farther in hundreds of millions of light years, the universe looks more uniform. The further away a galaxy is from a location, the faster it is moving away relative to you. Surprisingly, we can see as far back as 14 billion light years. Regardless of where someone is looking from in the universe, they will have relatively the same point of view as others. It is quite hard to locate the true center of the universe, since planets and galaxies, and other things as well, probably are expanding, and because of the sheer size of the universe. On the other hand, one could say that the center of the universe is where the Big Bang originated from. As a matter of fact, the whole nature of space and time relies on Einstein's general theory of relativity. Einstein stated that the inertial mass, which is how much inertia something has, and the gravitational mass, how strongly things gravitate, must always be equivalent. If you have a gravitational field, the force is proportional to the mass, and the inertia is proportional to the mass as well. So the first experiment I did was record sounds of I-35. Alright, so this experiment may help us grasp and analyze a variety of sounds of the universe. Analyzing the Doppler effect with objects on Earth, we can see how sound frequencies change from the distance to an object. How my experiment connects to cosmology is the sheer distance of the universe. My goal of the experiment was to see differences and similarities between sounds of the horn and truck at different distances, pitches, and speed. And related to light, distance, and sound waves of the universe. The honking of the horn sounded like this. Here's the sound of the truck moving by. As you can see here, this is called a waveform graph. It is the most generic in my opinion. The next is a graph. It is called the decibel level. It is measured in decibels and hertz, aka frequency. The last is the most interesting. It is a spectrogram. It measures how frequencies change over time. As you can see, I tried analyzing just the main orange and yellow line towards the end. This line is the truck moving by, the sound of the truck moving by. The second experiment was one where I was honking a horn while driving by. My goal is to compare and contrast the graphs of the two audio clips of the spectrogram on the Audacity app. Here are the three same types of graphs, but for the honking of the horn. So here's the analysis. As you can see here, I've put the two spectrographs next to each other. The top one is the truck sound and the bottom one is the horn. The horn was much closer to the recorder than the truck, so that most likely affected the results in some way. Basically, the honking of the horn had a more rigid end to the decibel graph compared to the truck going by. The decibel level graphs also had the same sort of shape at the beginning of each, which was interesting. The waveform graph for the truck over the whole recording time was on average louder for a consistent period of time, most likely due to the constant car noise. In summary, the car horn was louder at a higher pitch and a bit faster of a sound than the truck going by. That is a little background info on the topic of cosmology. I hope you learned something today. My knowledge is still expanding, so some of this info may be hard to grasp. Thanks for watching.